Hello, so this will be the presentation video of the paper titled Pre-Eating Play Fabrication Experiences for Playful Human Food Interaction. This is Michinari from the Bandai Namco Research speaking, and this work is a joint work with the Keio University. Digital technology have been integrated into various stages of human food interaction. For example, digital fabrication technologies are applied for gastronomy. Human food interaction is a growing research area, and researchers have categorized them and are working on them from many directions. There have been various research that work on food in HCI. For example, researchers have explored sensing human states and using such information for produced food, and also have been thinking about the design, shapes, and functions of the food. We believe that there are two main streams in this area, where some categories especially for eating have been explored in the context of play, and second, food fabrication research where digital fabrication technologies are applied for edible materials. But together in the pre-eating stage, food fabrication research has not yet been studied through the context of play, even we are aware that this area is validated as successful cases by products released worldwide. So this motivated us to explore playful pre-eating research, especially focusing on fabrication. Talking about pre-eating, which we think it can be understood to include every stages before the eating stage, in our work we mainly focus on the preparation stage, which is a stage where we make or cook food, and the consumption stage, where we can adjust the taste just before the eating stage, like adding salt or vinegar to the dish for a personal preference, and like we do not include the harvesting or growing stage for now. So to explore playful pre-eating experiences, we work on the area from three aspects. First, we analyze playful food products to understand the strategies of the design. Then second, we analyze whether previous food fabrication research in HCI can be applied for playful experiences. And lastly, propose an original method of food fabrication that can be applied for playful experiences. We will go into the product review. In our work, we picked up some products that are from our own group company and also from others that are more popular worldwide. We are not going in deeply into each product now, but as a brief example, if you think about gummies that are shaped like Lego bricks, I think it is easy for you to imagine how you will interact and eat them. You may make ideal shapes just like normal plastic toys just before you eat. By going through these products, we came up to find 4 elements that influence the experience of playing with snack products. Firstly, many products provided opportunities to design shapes or structures by the food. As like the primary interest of fabrication research, it may be important to allow users to achieve a self-designed shape. Second, there may be challenges designed in the product. It can be something like a puzzle or a shape or even the appearance of the food. Third, the above elements are not mandatory, and it's important to leave them as an opportunity. In other words, the product still can be ate without any special interaction. And lastly, the taste of the food is less found to be influenced. It can be something to design the challenge, but it does not seem to be an important aspect to design the experience. Looking at these features, we can notice that it shares elements with popular definitions of play, therefore can be understood why these products can provide successful playful experiences. Taking a look at food fabrication research in HCI, we found that these elements retrieved from products also had a good relation with them. Food fabrication research tends to design shapes and challenges, while they are not mandatory and also do not concentrate on the taste. So food fabrication research has a tremendous potential to be studied for the context of play, but what other opportunities can we explore? We decided to work on expansion of the food and also assembling. They are inspired by some toys. For our method, we were inspired by the theory of prawn crackers, which are made by tapioca flour and expand significantly when heated. Here we would like to show a quick video of what we do with our method. Mainly the dough can be designed and processed by laser cutters. We can cut them to ideal shapes and insert grooves to design the deformation. Other than using lasers, It can also be cut by scissors or more analog methods, just like traditional cooking or crafting methods. The idea of inserting grooves for the deformation is quite similar as more flour, which is based on flour dough, but our approach has several advantages where we can process them with lasers, and where it also has an additional dimension for shape design, where it can expand. For our approach, we conducted some technical evaluations from two aspects. Firstly, as we talked about the expansion of the dough, it was measured to expand approximately 4.1 times from the original volume. And for the deformation, we measured the effect of the grooves inserted to the dough, where those with grooves inserted showed a larger deformation compared with those without any grooves. Based on our method, we also propose applications imitating plastic model assembling, where one can cut doughs and create shapes of their own to play with. For more detailed information, please go through our paper. Thank you.